there is icosahedron. Then there is a rule. Each hexagon should have 1 through 6 different numbers. So if I draw the hexagon in this shape, I can have one hexagon here and two hexagon. How many hexagon can you say? 3, 4, 5, 6, and 7. So there are total 7 hexagons, and in each hexagon, I have to have different numbers. So I can start from 1, then 2, 3. That means because in the green hexagon, I already used 3, so I can put the 1 and 2 there. Then this hexagon should have 4, 5, 6, 2 in the yellow, so I can put the 4, 5, 6. That means in the green one, I can have 4, 5. Now in the blue, I need to fill out other 4 with different numbers. So I may put like a 1, 2, and 6, 3. Then if I look at this purple inside the 1, 3, 4, 5, 6 are already done. So I may put 1 and 2 there. In the red one, 4, 5, and I need to put the 1, 3, and 6. Then in the black one, 2, 4, 5 are missing. In the last one, 4 and 6 are missing. How? I followed all the rule and filled it. How? Because I already know the answer. We are going to make the computer solve this problem. So you are going to write the code. Actually, this problem is from Dr. Gabor. That's why I said Dr. G's consideration. And he was giving you some idea how to do this one. So I want to define the problem. You need to think about the variables. Actually, you are supposed to assign there are total 24 triangles. And each triangle will have a number. Then the domain will be 1 through 6. So each triangle can be variable. Each triangle's domain will be 1 through 6, integer numbers. And data structures. What data structures do you need? The dictionary for assignment? Or we can think about a little easy way like Dr. G's consideration, a string. I can think this one as one string. 1, 2, 3, 1, 2, 1, 4, 5, 6, 4, 5, 1, 2, 6, 3, 1, 2, 3, 6, 2, 4, 5, 4, 6. Do you see how I read? If I erase this, each triangle had its own value. So give index value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, something like that, up to 23. So index 0 has a value 1, index 1 has a value 2, index 2 has a value 3. How about if I didn't assign yet? I can use dot. So if I assign only 1, 2, 3, then dot, 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 4, 5, dot, 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 dot. So that can be empty one. That means for assignment, instead of the dictionary, this time I can use a string. That means not assigned yet. Then also I need a CSP table. CSP table means I had 7 hexagon. So this 7 complete hexagon needs to be CSP table. First hexagon's index will be 0, 1, 2, 6, 7, 8. So I'm going to make 0, 1, 2, 6, 7, 8 as a one set or one list. Then those index should have all different numbers. So you are going to make like a 7 list or 7 sets. It's going to be CSP table. Actually, this CSP table is given in your shellcode. So you don't have to write down. So lab name is the same thing, last name, first initial, and lab2. So sample input, it can start from the empty, so just 24 dots, or you can start from some parts are filled. Then you can display, there is an input in the main method, it will ask input string, then you are going to input. After you solve the problem, you are going to display. Display method is also given. But you have to also print the solution. Solution is just one string. Then there's a check method. So you can use that check method to check if your solution works or not. Then if I show you the shellcode, check complete is already given. This one is when you're gonna check at the end if it works or not. And select unassigned bar is valid, and backtracking search helper method are what you're supposed to do. Display method is given, so you don't need to worry about. And in the main method, the CSP table is also given because it's just a hard coding. This is a list of lists. So when you run the shellcode, it runs, then it says it's not solvable. You need to make it solvable.